Oh, that commodity is fantastic.
Thank you very much. Now, if we click on Start Experiment button, you can see that it gives appropriate controls to the user. Lasers can be enabled by checking a checkbox in front of it. Frequency and duty cycle of modulation can be controlled from the drop-down list here. On top of it, we are directly reading data from photodetectors PD1 to PD5, which is displayed here on the screen.
What are all those symbols around the lasers and the detectors that you have shown?
In Light Runner, along with 6 lasers and 5 detectors, we are providing some important passive components like 4-channel optical WDM mux and DMux, 3-port circulator, 50-50 splitter or coupler, 980 by 1550 WDM coupler, variable optical attenuator, fiber Bragg rating, and beam-doped fiber.
What are the experiments that can be performed using Light Runner?
Light Runner enables the user to perform at least 16 experiments on the state-of-the-art fiber optic communication technology. They include attenuation, dispersion, optical amplification, WDM link, optical add-drop multiplexing, RTDR experiment, eye pattern, bit error rate, analog and digital fiber optic links, time division multiplexing, laser and photodiode characterization, rise time and power budgeting.
Is Light Runner restricted for doing 16 experiments only?
Interestingly not. The experimental list of 16 covers almost all aspects of fiber optic communication, starting from basics of fiber optics to the state-of-the-art fiber optic communication technology. However, since Light Runner provides access to individual active and passive components, this experimental list can be expanded based on the user's imagination.
I agree, Light Runner is useful for learning fundamental and advanced techniques in fiber optic communication. However, will it be useful for research lab like ours?
Light Runner provides access to individual fiber optic components. Using the fiber patch codes provided, you can connect them with external components in the way you like. This means Light Runner's individual components can be used independently without disturbing the performance of components.
This seems to be interesting. However, will it be useful for me to train my application engineers for the field operations?
Yes sir, we have considered that aspect too. To that end, we are providing 3 different spools of telecommunication grade single mode silica fiber of length 500 meter, 1 kilometer and 2 kilometers. These are useful for learning how OTDR works and to calculate dispersion and attenuation for different lengths. Even one can learn bit error rate measurement and eye pattern analysis using Light Runner.
As you said, there are mux and demux. Can we establish a WDM link using these components? And what about EDFA?
In fact, we have included these devices in Light Runner with a view to giving hands-on experience to the state-of-the-art technologies in telecommunication like WDM and EDFA. We have all components required for constructing a WDM link. This is the specialty of Light Runner. The EDFA given is modular in nature for its complete understanding. One can assemble EDFA from its basic components provided on the backplane of Light Runner. The list of experiments possible on EDFA here ranges from forward and backward pumping, optical gain variation, single and multi-wavelength amplification, etc.
I can see these mux and demux are the ones which we are installing in the field, so that it will be interesting for me to train my engineers for the field.
I can see some waveform on this computer screen here. Do we need our CRO to be used with Light Runner?
As I mentioned at the beginning, Light Runner requires only 230 volt power supply. Light Runner boasts a 2-channel 60 MHz DSO hardware inside and its front end is on the notebook. DSO has the facility to store data and trace with different measurement options like average taking, rise time measurement, FFT, etc.
Wonderful.
That's why Light Runner stands at the top.
I could see many things lying on the table as part of the Light Runner. Could you explain me the roles of all these things?
Oh, you mean the LCD monitor, the optical power meter, the multimeter, optical patch codes, etc.? Optical power meter is useful for absolute optical power measurements at multiple wavelengths. Multimeter is needed for laser diode current and its monitor diode current measurements. LCD monitor, which is an add-on to the notebook PC, is for a clearer vision of the software controls. Optical patch codes are for optical interconnections. In addition, Light Runner comes along with a comprehensive manual prepared by Professor K. Tyagarajan and Professor Emma Shenoy, who belong to IIT Delhi. Do you have some more questions?
Light Runner seems to be an ideal solution for all my teaching needs.
Light Runner gives an exposure to the students to the state-of-art technology like WDM and EDFA, which are used in the fiber optic communication.
I endorse your views on Light Runner. It will be highly beneficial for my engineers to understand the concept and working of OTDR, bit error rate, I pattern, EDFA, WDM, power bursting and rise time.
Beyond these all advantages of a light runner, I can use it as a friendly utility for expanding my research horizons.
On behalf of Fiber Optica Technologies Private Limited, I thank everybody. Namaste.